Okay, class, let's just have a quick lesson today. Geometry again, talking triangles, a great shape, worth our time here. The key with triangles today is classifying them. Classifying means putting them into groups, labels, whatever you want to say. You can classify cards, you can classify bugs, you can classify friends, you can classify anything. You put them into groups to help us keep them all straight and stay organized. Triangles can look a lot of ways. They can look like that. They can look like that. Goodness, they can look like this. As long as it's three sides connected, it's a triangle. But there's different types. And to make it more confusing, we could call this triangle two different things depending on whether we're classifying by sides and their lengths, like equilateral, which means equal sides roll. Or we might call it by its, what do you think? Angles. You could call the same triangle two different things. We could call this, because all the angles are below 90 degrees, what do you think we might call it? An acute triangle. So two ways to label it. Very important to remember today. It's either by sides or by angles, or both if they ask for that. Can you explain in your own words how the number of equal sides of a triangle compares to the number of equal angles it has? Think about that. Triangles are three-sided polygons. Not all of them are alike. We can distinguish them differently, classifying, first of all, by sides. Let's start there. Classifying by sides, you have the equilateral, like I mentioned, meaning all the sides are exactly the same. I can show that with equal tick marks. This is the word isosceles. Can you say it to me? Isosceles means two or more of the three sides are equal. Equal, equal, not equal. So I suppose an equilateral is also a type of isosceles, but it's even more specifically equilateral, because it does have at least two equal sides. Scalene, say it with me. Scalene. All sides have different lengths. None of them match. Scalene kind of runs with its own crowd. None of it matches. It's like the triangle that comes to school with two different types of socks. So how do the equal sides compare to the equal number of angles? Really, those should match up if I'm not mistaken. So you learned three types of triangles. Wouldn't be a bad thing to define and write an example in your notes for each, in your math notes if you've been keeping up with those. Kind of answered this. An equilateral triangle is kind of an isosceles as well, but kind of like if you have a square, let's not just call it a rectangle. Let's get as specific as we can. And I promised we'd also classify by angles. Acute means less than 90 degrees. So the triangle has all three sides less than 90. That might be an equilateral. It might be a scalene. The point is the angles are the same. Or not same. Less than 90, excuse me. Right or perpendicular, 90-degree triangle means you have one of these angles marked with a box showing its perfectly perpendicular base and height. Can you have more than one 90-degree angle in a triangle? Well, let's see. 90, 90. Uh-oh. If I connect these, I'm going to have four sides, right? Because 90 plus 90 is already 180, and 180 degrees is all we can get into a triangle. Does that make sense? And the opposite of acute is obtuse, more than 90. Now, you can't have more than one angle that's more than 90. We even proved that you can't even have more than one angle that is 90. So just one is takes. One angle is obtuse, and in this case looks like this guy right here is obtuse. Each angle of an equilateral triangle, equilateral, which was the previous page, each angle in this guy is 60 degrees. That's always 60, because if the sides are equal, like I said, the angles are, the same number of angles are equal. So if you need three equal angles to get into 180, that's going to be 60 times 3 every time. Okay? So that's that. Why don't you answer all of these? Because they're quick. Some of them true and false. Lesson practice A through E.